He wants to pay to download the game. You'll be able to reap the benefits. In short, others have to pay to use this feature. We are talking about the same. In terms of the entire device now. Vendor equipment has outdated functions and no innovation. It does not matter. I now open the interface to it. Many people can come in and develop. Not only Cisco. Many other manufacturers can come in and develop. Only need to develop these functions. Upload to this platform now. Upload to such an interface. Can be used by others for a fee. It's like a store. The SDN controller has a hardware in the web. Everyone can see the interface intuitively. This thing doesn't look like that on the command line. No need. We have a graphical interface. Can come in for development. We call it support for third-party development. Equivalent to accessing more developers. Opened up. Now if the user wants to use, you can spend money to buy this device. Please note, its difference is, originally only Cisco devices supported EIGRP. Now this device supports SDN. Then open the corresponding port on the SDN controller hardware. All these services develop throughout the platform in the future. As long as the device supports SDN now, can be downloaded and used. It is not required to be a device of a certain manufacturer. But not yet. For now. Cisco's SDN hardware can only control Cisco's. So, there is no real implementation of such a form. Not really open up. Some people may think, isn't this equivalent to letting yourself spend money in disguise? Actually not. Like some functions you use on the device now. Also have to buy a license. In the future. These functions are just another way. Then let you pay to use it. It prevents multi-vendor incompatibilities. You will find SDN is facing the current stage. SDN that most students come into contact with. In fact, they all refer to the control hardware of enterprise-level SDN. These functions in the SDN that I just talked about. In fact, it is not the core function of SDN. Only when you get the IE stage can you know its core functions. Now I can only tell you. There are actually quite a lot of things we can understand at this stage. Let's talk about its development. The beginnings of SDN are open source. It was started based on the Linux system. This is an open source system. Supports secondary development. It was originally a professor at Stanford. In order to solve the problem of complex network and high cost of the current project, developed a system. Notice. It develops a system. It is a software. Developed an SDN controller system. This is a software. It doesn't sell hardware. This is free software. This system can be installed on an ordinary server. Install on normal PC. Install on cloud server. All okay. It can be used as a core node of network management. No matter where it is installed. This device is a core node. These downstream devices only need to support SDN. Like I said, this can be controlled accordingly. This saves the business money. The following equipment does not need to buy such high-end equipment. All you need is a device to do the calculations. Although the idea is good, but no manufacturer is willing. You now hope that the underlying device does not need to calculate. It's all white box. Manufacturers are now developing so many high-end devices that they cannot sell them. So in fact you will find it is not so simple from the perspective of technology development. Often there will be more in-depth content. To us. Now we have two organizations. One is called ONF. They develop systems like ONOS. It is more compatible with operators. That is, specifically for carrier networks. Then the software developed by ODL is also called ODL. They are geared toward data centers and enterprises. It is more of the current networking architecture. Into two directions. In fact, they get a lot of support. Especially like ONOS. Actually, they have a lot of support from operators. Because for operators, I have to buy a lot of equipment from manufacturers every year. So they are kind of very ambiguous relationship. Just a good relationship. But in fact, they are also a relationship between paying and being paid. So they also want to save money. To put it bluntly, the operator has a lot of things. Hope to save money. If so, the equipment they buy every year does not need to be so high-end. This saves a considerable amount of money. So we will support accordingly. But I also said, vendors certainly don't need to see open source. All devices are now available for the entire market. Everyone does not buy high-end equipment. What about our equipment? But now organizations are starting to develop such technology. The manufacturer also has to develop. If the new generation of technology in the future is getting stronger and stronger, so as the world's two largest manufacturers, they must want to stand on the wind. That is, the development of technology cannot be truly stopped. What they can do is invest. They will also invest in organizations like, for manufacturers, the investment in ODL is significant. For operators, investment in ONF is significant. For this organization, many manufacturers are investing in. For such an organization, they get a lot of investment. Including now if you want to download. It can also be downloaded directly to their official website. With controller. After downloading. Can be installed in a virtual machine. But it's useless. Because you can't control the device. No device is compatible with them. So I gave up completely. When manufacturers invest in. Will also wait and see while investing. And develop their own technology. Let's talk about DNAC next. Called DNA Center. This is Cisco's main control hardware product. Now a device like this. It is more about the support for Cisco's SDN equipment. Actually, for you at this stage. First of all, I can't understand. Secondly, there are no scenes to give you some corresponding explanations. But I can tell you a few functions inside. Some friends may feel a little puzzled. Since they don't want to develop. Why are you pushing your own product now? Because they are investing now. To invest is to become a shareholder. Technology itself can be shared by everyone. It is not shared. But many core technologies have actually been obtained. And there are also core personnel to learn from. So you will find, after the investment is completed, the overall routine manufacturers there are already clear. Then they can start investing in their own products in the market. Cisco didn't sell hardware in the first place. It sells software. Called APIC-EM. They don't just sell this. They push a free software like a public beta version for users to use. See how the market accepts it. If the market feedback is good, then put together software like this. Sell with hardware. There is now a piece of hardware. Support software functions. And tell the user. They have some new features. If the user feels okay, we'll buy their hardware. Let me briefly talk about a few functions here. The first one is SD access. Software-defined access. In this future you get the data center environment. To really feel what it means. I1 is now called SD1. SD1 was previously called Wisdom Wide Area Network. Now it's called Software Defined Wide Area Network. It can be done in some large networks. Some traffic load on egress. For example, engine room, bank, etc., including special projects we will handle in the future. And our daily traffic export are capable of loading, is quite powerful. But now for businesses. These things are not used in the enterprise. So let's talk about some things in the enterprise that are helpful to everyone now. Let's talk about this base automation first. It means the upper device automatically sends the configuration. The following equipment automatically completes the automated deployment. It's called automation. Then plug and play. Automation goes online. For example, there are a lot of smart speakers now. Once connected to the internet, it can talk to you. This is called automation. The router automatically connects to the network. It finds the SDN controller by itself. The SDN controller reversely controls the downstream equipment. Start delivering fixed configuration. It's called plug and play. You don't need to configure it anymore. Look down. Monitoring and troubleshooting. Monitor the health status of some devices in the current network. For example, device CPU usage, fan operation, etc. Give appropriate diagnostic opinion. That is, now there is no need to set up network monitoring for that fee-based service. No need to buy now. SDN controller hardware can give you monitoring. Monitor interface bandwidth, CPU usage, memory, fan, device log. Provide you with corresponding alarms.